So in example 3, we're just trying to really make this idea super clear. We're looking at the trig functions of the quadrant angle. So we're going to be looking at 0, pi halves, pi, 3 pi halves, and what those sine and cosine values are. So this should be fairly simple since we've been talking about it for a few days. It says evaluate the sine and cosine functions of each of those. To begin, choose a point on the terminal side of each angle. And so we've chosen these points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. It says for each of the 4 given points, this radius value equals 1. So we are, of course, in our unit circle, r equals 1. So we are understanding right now that the sine of 0, that's our y value. The sine of 0 is equal to 0. The cosine of 0 is equal to 1. That's our y, that's our x. We can do the same thing going around the unit circle. The sine of pi halves is 1. And the cosine of pi halves is 0. All the way around. Here we go. The sine of pi is 0. The cosine of pi is negative 1. The sine of 3 pi over 2 is negative 1. And the cosine of 3 pi over 2 is 0. So we have this new concept. We've been using it, but we're going to have a name for it now, finding reference angles. And it says finding the reference angle for any angle greater than 90 degrees. The thing that we are going to do is take that terminal side. For example, in this first picture, we're going to take that terminal side. We're going to go to that vertex and drop that line straight down to our horizontal axis, which means to us always the x-axis. That gives us our reference angle, which will tell us all about the angle that we are discussing by the terminal side we just drew. We're going to call this angle theta, but this angle, the one inside, the new reference angle, is theta prime, and we're going to refer to that as pi minus theta radians, or 180 minus pi theta degrees. In the second case, so we can see we can have an angle in quadrant 2, we can have this angle in quadrant 3, our initial angle theta, and our reference angle theta prime. So theta prime, we drop that line back up to the x-axis, and that creates our theta prime angle. And in the third situation, we have our original angle measure theta. When we drop that line to the horizontal axis, we are creating that angle theta prime. And theta prime in this case is 2 pi minus theta radians, and in degrees it is 360 minus theta degrees. Back to the other page. For the second case in quadrant 3, again we have theta minus pi radians, and for degrees we have theta minus 180 degrees. And those are the values of our reference angles. Let's look at example 4. It says theta is 300 degrees. Find the reference angle theta prime. So we'll just do one of these because 300 degrees lies in quadrant 4. We're going to go 300 and just less 60 degrees. So let's draw that in right there. Here's our 300 degree angle. Theta is 300, And we need to find that reference angle theta prime. And what we just went over is this. In quadrant 4, we're going to take 360 and minus that initial angle theta, which gives us our reference angle of 60 degrees. We can do this with radians, just as I showed, and we can also do this with degrees. Why don't you go ahead and try problem number 65, and we'll come back here and talk about that solution. Problem 65 asks us to find the reference angle theta prime. It says sketch theta in standard position. What we need to realize here is we have negative 1.8 radians, so we know we're going backwards. So we have the radian measure negative 1.8, so we know we're going to be coming clockwise. I want you to think about this value pi 3.14, half of that gives us 1.57, and our angle measure is negative 1.8, so we're going to come around just past that negative y-axis, and that would give us very roughly negative 1.8 degrees or radians. And what we need to think about is this reference angle. Well, we know this entire negative angle to pi is the difference, or what we're looking for is the difference between pi and that 1.8 value. And if we do that, we should get the reference angle 1.34. I know most of you have spent some time memorizing patterns for the unit circle, but I'd like you to look at the bottom of page 287. That gal's holding up that sign. She says theta, our angle, 0, 30, 45, 60, and 90. The pattern in the sign of that angle is square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, all over 2. So those are handy little tips to keep in mind when we're trying to work with the unit circle. Let's look at example 5. It says we want to find the cosine of 4 pi over 3. Well, we have, again, a non-acute angle. So we're going to find that reference angle for 4 pi over 3. Well, I know that pi is 3 pi over 3, and if we take the difference of 4 pi over 3 and that, we get a reference angle of 1/3 pi. Well, I know that 4 pi over 3 was past the pi value, and now I know by a distance of 1 pi over 3. I also realize that we've got this angle, and cosine in this quadrant is going to be negative. So we're taking the negative cosine, because we realize which quadrant we're in, of pi over thirds. And we can remember from our unit circle, or quickly calculate in our heads, that value to be negative 1/2. I'd like you to look at the rest of the examples there, B and C, and then try problem number 77. Come back and check your solution. So let's go ahead and think about this coterminal angle. We know we're going in the counterclockwise direction, and I like to think of it like this. 6/6 would be 1 pi. 6 more would be 12/6 pi. And 6 more would be 18/6. So we are 1/6 shy. 1/6 shy of being another 6 around. So we're going to draw in that angle roughly, very roughly. So we can see that we are 6/6 plus this extra 1. We are our reference angle 7 pi over 6. And in problem 77, we're asked to do the following. Evaluate the sine, cosine, tangent of the angle without using a calculator. So I'm going to draw this angle out here, and here's what we know. We are in third quadrant, and we understand our sine to be negative, our cosine to be negative, and what else were we asked to find? And the tangent. Now, tangent, negative over negative, we're going to have a positive angle there. So cosine is negative and sine is negative. So we can conclude this. The sine of negative 17/6 pi is the same as the negative sine of pi sixth, and we find on our unit circle that to be negative 1/2. Now the cosine of that same angle theta that we were originally looking at, negative 17/6 pi, is equal to, just as we said, the negative cosine of pi over 6, that reference angle, which is the square root of 3 over 2. And then we consider the tangent. The tangent of that negative original angle is equal to the tangent of the positive reference angle. Tangent of pi over 6 is equal to square root of 3 over 3.